Hello, everyone. I'd like to welcome you to our panel. So today we have a topic that is near and dear to all of our hearts. We're on this panel, and this is security must match software delivery at light speed. And I'm going to go ahead and introduce you to the panelists. And I have Anmol Misra, who has over 15 years of experience delivering software solutions for global companies, most recently at Autodesk. He's responsible there for the security and compliance of over 300 customers and enterprise applications running in cloud environments. He's the author of Android Security, Attacks and Defenses, Core Software Security, Security at Source, and a contributing author of Defending the Cloud, Waging Warfare in Cyberspace. And I have Damilare Fagbemi. He has over 12 years of experience delivering solutions for global companies with an emphasis on core software security. He's active in the OWASP community, both locally in Arizona as well as globally in Nigeria, and is an active speaker on the topic of software development and security. Most recently, I had the pleasure of seeing him speak on the panel at FuzzCon during Black Hat. And he is the co-author of a book called IoT Architect's Guide to Attainable Security and Privacy. And last but not least, Brook Schoenfield is a security architect with decades of technical leadership experience. He's most recently providing security architecture leadership for 3 security consultancies and is an advisor to 2 firms. He's the author of Secrets of a Cybersecurity Architect, Securing Systems, Applied Security Architecture and Threat Models, and is the co-author of Building Security at Agile Speed, and also a contributor to Core Software Security. So suffice to say, we have some of the world's experts on the topic of software development and software security. And what I'm going to do now is I'm going to ask each of our panelists to give us a little background, more on the lines of what brought them to where they're at today with regards to this thinking. And it's just a little background holistically of the aha moments that took them to where they are and some of the things they've experienced in the field, which is effectively the world we live in today with billions of lines of code, et cetera. So why don't we go ahead and begin with Brook?
Thank you, Mike. It's been a long journey, as you said, decades. When I first started, we really were like the specialty folks who were watching developers and making them be careful and writing rules for them and policies, and we didn't even get to standards yet. And I think the big aha moment that we were doing it wrong and we're not as effective as we could be was 2 things when I was at Cisco. One was I started working with agile teams, and I saw how all of this participation and everyone working together and having some control, and how intimate and also iterative things were. And our whole idea of, well, we're going to come in at the beginning and come in at the end wasn't working. What we got a lot of the time was, I'm sorry, everything changed and your requirements didn't change, so we couldn't implement them. And that was a really powerful lesson. And the other thing that happened is we just simply couldn't scale. We had 5,000 developers, hundreds of projects, simultaneous projects, and 2,800 apps. And in my portfolio that I was, supposedly a leader for. And what we needed to do was figure out how to get to build security in on each team. And that we were probably one of the first in what we now call security champions, and we can argue about whether we like champions or not as a term, but we were desperate. We did it out of desperation because we couldn't hire enough security architects. And so, but it was so successful that within a year, everyone across Cisco were asking us, how to do that? How does that work? How do we do that? What's the secret sauce? And it was really a powerful lesson and out of that grew my offering to the universe, if you will, to the industry of developer-centric security. It didn't go anywhere. I don't think more than 10 people actually read that manifesto, but it's okay because it was a start to really rethinking security in this other way of, yeah, my job is to enable and empower you and help you as opposed to checking up on you. And that, then there's been a journey learning about, if you're still doing, I'll just say, if you're still doing security like you were doing in 2015, you're probably got some things that aren't working very well. Check.
A lot of sense. Anmol, you want to follow with that?
Sure, though that's a hard act to follow. And thank you, Mike, for that generous introduction. My journey in many ways is how a lot of us get started. I was a sysadmin and then ended up in development, and I was a developer and really saw how we either maintain and build systems or software. And then when I went into consulting to really look at how a lot of companies do run their programs, whether it's security, privacy, or compliance, and then how they come together really to solve the main issue, the security risk. Right? That's really where a lot of formative experiences come into play. And then, of course, with Brook at Cisco, trying to build security into what was then, Brook can correct me here, was one of the first SaaS applications at Cisco to be hosted out of its cloud. And so again, trying to figure out how to do software security from the get-go to the deployment, and doing that in the constraints that would come in a large enterprise environment, right? So that was, again, things that we picked up at Cisco and then, of course, at Autodesk. So to me, building on what Brook said, right, if we are doing the security the same way we did 15 years ago, we haven't solved the problem for sure, because I think we have a roadmap for next 15 years, apparently, and all the tools that come when we need to deploy. But B, the idea that we have got this right and we don't need to change it, we don't need to adapt and scale, actually increases security risk and gives you a false sense of security if we continue the traditional practices without tweaking them.
Great, thank you. Damilare?
Thanks so much to all the folks who've joined us today, and really thanks to Kim and FutureCon. I love that name, FutureCon. It just resonates. I met Mike just over a month ago, and it's already been such a privilege, a real treat to know you. I've known Brook for a few years now. Brook mentored me quite a bit at McAfee. I learned a lot from him, such that I know that it's likely if I hadn't made Brook, I probably wouldn't be on this panel. And I remember when I got into software security, Anmol's book, Core Software Security, was one of the first books, that I read. So I feel really honored to be in such good company. And in terms of my journey, how I got into software security, or my aha moment, I was in Nigeria at the time. That's where I'm from. And I remember I was building this app that was to be launched with press, actually. So there was quite some awareness about this platform that was to be launched. And as we launched it, long story short, it got hacked. Now, there was this really small team working on this app, and we were just thinking about getting the app to market. We're not thinking at all about the security side of things. As we launched, the app got hacked. And of course, now I began to think, oh my gosh, what is this intersection of software and security that I was not thinking about at all? So my journey took me into software security engineering at McAfee, where I met Brook, into security architecture at Intel, working across diverse teams, diverse platforms, diverse architectures. And I could see that some of the struggles really across these different organizations or different teams, even in one organization, sometimes it's the heaviness of the process and the difficulty of streamlining that security process or software security process to the development process. Now, summarizing my long story here, founding resilient software security really recently, I've been engaging with a lot of startups and small software businesses, and I'm finding something that is very similar to what I saw even while working with folks like Intel and McAfee. Now, with small software businesses and startups, I often see that they consider software security to be this heavy, expensive process that they're not ready to deal with yet. We're not ready for that heavy work now. We're not ready for that expensive work now. The irony, of course, is that the later you leave software security before bringing it into the development process, the more expensive it is. Also, when such small software businesses or startups actually get compromised, they're just building trust, so they find it very hard to recover. So something on my mind is, how do we get out of this perception? How do we overcome this perception that software security is a heavy, expensive process? Because the truth is that today it really doesn't have to be. With the right automation and with the tools that are available, the software security process really should be tailored for your organization, for your business, for your stage, and things like that. So thank you once again. I'm looking forward to this conversation.
Great, thank you. And it's interesting, Damilare, the mention of the word automation kind of brings me to the next point. When we first began speaking as a group, we talked about one thing, which I think is just sort of amazing. I've known Brook for quite some time. And back then, we were always talking about shift left in the SDLC. We are still talking about that 10 years later. And the question is, one, why? And two, is there a solution? Can we actually get to the point where we're no longer talking about it, we're just doing it because we are actually keeping pace with software development? And by keeping pace, I mean security is no longer a stumbling block, a gatekeeper. It's actually there to facilitate and make things faster. And next question is for Anmol, because your background in using AI and ML, what are your thoughts on the future of security with regards to automating, speeding the process, and somehow helping us keep speed with delivery? And Anmol, that one's for you.
So should I go first, or Brook? Do you want to go
please.
First? Okay, thank you. Thank you, Mike. So with AI and ML, I think we have talked about this before. I don't see true AI out there being used as much as I see, some sort of, data-fed models that pick up and do things that we want. That's very different than true AI. So as far as the use of AI in some of the stuff that we do, I think there's promise, but I haven't seen that come mainstream as of today. But that's really where we'll be headed. We should make sure that while we, to your point, right, if we are talking about this 15 years shift left, right, we need to somehow fix that, because really the next sort of battleground would be attackers leveraging AI to come at us. And we should be then thinking about how, A, to prevent it, but B, how to use AI to get better at, optimizing the right kind of commits from Git all the way to deployment, right? That's probably one place that AI could be more helpful given the context of the risk that it can help us with. So that would be my input.
Great, thank you. Brook, thoughts on automation, AI, ML?
Underline what Anmol just said into the future. We're really at the very beginning here. So where this is going to go is going to be very interesting. Nevertheless, I'm going to come back to what we can do right now, because there's some significant automation. And the thing is, automation is moving really fast in software development around a lot of areas. And I feel like security is always playing catch up in an interesting way. What's the word I want? Not just playing catch up, but it seems like the security tools are like 2 steps behind what developers are actually doing. And then there's this lag. So just take the shift left that you were talking about a moment ago, Mike. And I, by the way, folks, anybody listening to this, I don't really like the linearness of shift left, but early, at the right place, doing the right things at the right place when you're building software. And there are things that happen early, like when you're coding or when you're thinking about coding. So, let's talk about it that way. And what's happening is, we understood years ago. I mean, when we wrote core software security, We already knew we'd love to have some kind of security analysis while someone was coding. And we were trying to push that really hard. We're still trying to push that, and the tools are still fairly weak in this area. That's a lag of 6 years right there, 6 to 7 years. And that worries me, because developers are delivering code, especially in web environments, like every hour, every 10 minutes. And so they're coding. And one of the problems is, once you stop coding, having written hundreds of thousands of lines of commercial code myself before I got into security, I can tell you, once I stop coding, I want you to prove to me there's an error, because I've done my absolute level best to remove the errors, right? Using every tool at my disposal, as long as it's not too heavyweight or too long. So what we want is coding. We want to be able to check my coding as I go. But that's got to be lightweight enough that I'm not sitting there twiddling my thumbs for 40 minutes, waiting for some process to finish before I make the next coding, because I can generate 1,000 lines of code in a day when I'm really on. That's a lot of code in a day. You figure 100 lines of code a day is really good, or used to be back, and I'm old, so who knows what people expect from people today. But it used to be 100 lines of code, and I can write 1,000 lines of code in a day, or I have more than once. And that's when I'm really on and I know where I'm going and what I'm doing. And that's a lot of code. I can't be stopped for an hour sitting there twiddling my thumbs looking for something to do. So if you can have a process that's checking, that's quick, like compilation, just quick like that, it really helps. And there are some new tools that are looking in that area, and they're fairly robust. But are they everywhere? No, we're still looking at, well, I'll send my code to the server and maybe I'll check a little bit of it, or just what I wrote. But are we looking? So, automation. And then there's the problem of stuff that's still craft. And that's a problem that's being addressed. There are threat modeling tools that are getting pretty mature. I'm not going to name any names here. You can just go out, audience can go out and look and look for themselves. There's a couple of tools that I think are quite mature and have been around for a while. But, is that the standard? Does everybody have them? No, they don't. So, where can we automate? And recognizing that coding and design still involved craft that require human analysis. And that's going to be true until the AI is actually writing the code. So while we still have that world, we still have a world where there's stuff that can't be automated. So I don't want to hear from anybody, oh, just automate everything. We'll automate security away. I don't think that's going to work.
Not yet.
Not yet. Come in there and just add to what Brook said. So AI, I think, you heard his sentiments. Automation is probably the key on how successful we will be from here on. But there is a craft element that at the moment, we can't get away with that we mentioned. Now, think of automation or the way we solve this problem, right? You usually try to get some tools, a bunch of tools. For every 1,000 lines of code a developer checks in a day, multiply that, like you have thousands of developers, and these then tools, they have to be deployed and maintained, and they have to work every single time you're checking in code or through the rest of the pipeline in today's world. And it has to do that every single time at scale without slowing developers down. I think the problem is not so much in tools. The problem is, how are we using them, and have we really thought out this end user developer experience? Because we approach it from security experience, right? This is a review. Let me tell you what's wrong with your lines of code. But have you thought about what Brook was telling? When a developer is writing 1,000 lines of code and they are really onto something innovative, right? How are we not slowing them down? That is why we are still talking about this 15 years after shift left.
Wow, yeah, that's great perspective. Damilare, I have a question for you with regards to automation, and also just for the audience in general. Our panelists are amazing, if you haven't noticed yet, and they're going to give you some takeaways. Like what the next question is, like, Damilare, if I were your customer and I came to you and said, man, I want to get this right, I want security not to be a stumbling block, how do I speed things along? What can I use today to help me be better at this? Because I recognize that the world that Anmol just described is a little bit on the terrifying side. I mean, it really is. And that's the world we live in. So what would you recommend to a client to say, how can I do this better like tomorrow? Whether it's a tool or a methodology, what would you recommend?
I love that. That's a great question. And it really covers just what Brook and Anmol have been talking about. So for instance, if a client were to come to me today, how do I speed things up? Well, I think for starters, it's good to acknowledge the value of that mindset that people seek to engage, and how do I make the heavy process not so heavy. But going back to what my fellow panelists were saying, yes, there's been a dearth in maturity of tools, but they are beginning to be tools that are mature enough in terms of the holistic end-to-end perspective that bring some speed, or quite a lot of speed, to the software security process. So not to multiply words too much, if we take the architecture and design of a particular application. So there are tools that we can use today. Like Brook mentioned, threat modeler, there's ST elements that helps people to have some threat modeling and security architecture work in an automated fashion going on even as they kick off a project, such that requirements for that project are already coming out of such a tool. Now, if we go into coding as well, and we think about, say, static analysis, there are some tools, for instance, that are more, shall we say, smarter for the environment within which the developer operates, because that's one of the problems with automation in general, being that many of the tools that we see are not feeding right into the environment in which the developer operates. But with static analysis, I'll say, yeah, there's still some issues there in terms of speeding things up, but you have some environments, like let's say the Microsoft's static analysis tool that is right there in the developer environment, such that super write code, they're able to see secure coding errors as they develop. So now the choices there, though I don't want to say like a magic wand, the choices there would depend on the programming languages of platforms that developers are using. There are some platforms as well whereby if people are using things like AngularJS, whereby the language itself is already designed to eliminate a lot of the common mistakes. So when you have companies using such languages that are designed to eliminate some of the common mistakes, doesn't mean there's nothing else to do, but secure coding gets a little bit easier. Now, when we go into this, the concept of all the third-party components that we get today from, say, from just the open source world, we're not trying to reinvent the wheel. We begin to find that there are tools as well, say tools like Snyk, that help you to ensure that the third-party components that you're bringing in you're on top of your vulnerability state, so to speak, such that you're easily able to update your systems and patch your systems, even as part of your continuous development pipeline. Such a tool like Snyk, as an example, also it allows developers to bring patches in or commit patches as the tool runs, such that it's not this separate tool that's run, it's integrated with your software development pipeline, and it creates code commits that can be brought in as vulnerabilities are discovered and monitored in the third-party components that a particular developer is using. So a lot of words, but my point being that you have languages that you can use to reduce your risk. You have static analysis tools that work in a developer environment. You have architecture threat modeling tools that bring some automation in. You have third-party management tools that feed into the software development pipeline and allow you to click a button at the simplest to bring in patches into third-party components in your environment.
Nice. So quick question with regards to Snyk and other scanners. My understanding is so many of them today are able to identify vulnerabilities, but then the onus is upon you to actually manually remove them. And that sounds like a bit of a problem, I would just say, is just with regards to automation. Are there any solutions out there that you know of that might automate that completely so that you're not finding and then manually removing, but they're actually being removed for you?
That's a good question. I'm really curious to see what the other folks here have to say, but the tools that I've come across the way they reduce some of the work is that they give you, well, yes, they create those patches that you can then just bring in. But in my experience, usually you have the option though. That's the thing. Many of these tools, you have the option to let the patches be committed automatically. But there's just some risk in the sense that sometimes developers will still want to be sure that those patches don't break anything. So I think one of the ways that one can solve this problem is by setting up an environment, shall we say, an environment that is not your production environment, but close to production environment, such that you can automate some of this patching of scanners into that particular environment, and then you can run some of your sanity tests in that environment before automation also takes that part of the code or that part of the platform into production. So long story short, there's usually the option to let those patches be committed automatically, but people then decide just because of some concern of breaking the system to go the manual route of verifying the patches before committing the patches. But that's not the only way. If you have your infrastructure set up such that you have a dev environment that's close to production, you can automate how that comes in and how that is patched.
Nice. And Brook, actually a similar question for you, but more specifically dealing with finding issues in code that can be potentially breached with security issues like cross-site scripting, SQL injection. Are there any tools out there that you find are able to help coders find and fix quickly?
Yes. Well, I'm going to say every coder ought to have SemGrep in their IDE. I don't normally name tools. I'm very careful about that because I don't want to necessarily push one vendor over another. They all have their purposes. And that's actually another thing. Thinking that you can fix this with one tool, and I know these tools can be very expensive, so that's a problem. But thinking you can fix this problem with just one tool, I'm going to swipe it all away with one tool, and the vendor's marketing doesn't help sometimes. Solve your security with my tool. Those kind of statements are ridiculous, I'm sorry to say. But, there's not one tool, but if you're looking for something on the desktop while coding, I'm very impressed with the set that's in SemGrep. Its default rules are quite robust. And then you can make new rules, of course, for stuff you need to do. And people are making rules all the time. So you can add in if you have a particular language that's sort of edgy or something like that. But SemGrep is really, because it takes a different view of this universe. Instead of saying, this is a vulnerability, it says, normally when you do this sort of thing, you really should look at your code for security. And here's the sorts of things you should look at. So it isn't finding vulnerabilities so much as the places where vulnerabilities come in, which is a very different view. And it's also lighter weight and it's relatively fast. You can put it in any make file, any kind of, you can run your make file and it'll just run in there. So that is something I'd like to suggest to everyone. And the other side of that is when you're getting information like that, you're always, as a coder, getting training sort of constantly. You're saying, oh, yeah, right. Whenever I do X, Y, Z, I should be thinking about the security implications because SemGrep always tells me, hey, that's a security place. Can you think about that a little more carefully? And I think that's a very powerful tool in terms of training, immediate feedback, because coding is an art like playing an instrument. And you don't learn to play Rachmaninoff's second piano concerto as your start off, unless you're Yo-Yo Ma and you start with the Bach cello suites. Yes, he did at 5 years old, but the rest of us are more human, right? And we start a little bit, you write hello world in your first thing and you go, oh, that was cool. Now what can I do? And so it's a practice and you're always biting off a little more. And SemGrep, or a tool very similar to that, tells you while you're coding, hey, you keep making this mistake. Oh, I should learn about this, right? And that's very powerful. So if there was one tool I would recommend, is for people to get SEMGREP, and there's an open source version. So, that's very powerful and it's low cost and you can just do it. So why not? And it'll make your coding better. That would be the one thing that I would say, along with, you can't cure this problem with a single tool. If you do, you end up with --all, which then throws tons of false positives and noise, and you get frustrated. And I'm going to tell you about some cues. A company I worked at where I led software security, technically, one team had 72,000 findings and another had 46,000 findings. Guess how many they actually fixed? 0, because that's overwhelming. And so, it's got to be something you can deal with. So trying to get all with a single tool is not going to work. So it's going to be, this tool works better with this language and this kind of environment, and that tool works better with it. So always think multi-tools in today's world. When we get AI that's writing code and checking code, maybe we can get out of that universe. To Anmol.
And again, probably not tomorrow with that, but at some point. So Anmol, I have a question now with regard not to tools, but more aligned with methodologies. If you were to be approached by someone who said, look, you've been doing this at your current day job, like, what can we do to do it better? Is there an approach that we're not taking? And just in general, how are you approaching this? Because you've given this a lot of thought, and the world we live in does seem somewhat terrifying. And I'm just thinking in terms of, what advice would you give someone just to, here's an approach that might help you shore up the defenses and make things a lot more streamlined and faster?
It goes back to what Brook was saying, right? In today's world, I think what I do see a tendency to use tools as the answer to solve all the problems. They have the space, but I do think the thing that probably is missing in many of these programs I talk to my peers in the industry is the tools are probably not aligned with the processes and the culture of that company. Or there are overlapping tools resulting in that hundreds of thousands multiplied by X number of tools. Now imagine you give that to your developers and then send it up the chain. It is not only overwhelming, it essentially is saying to you, you should not do any more new feature development, fix these 100,000 issues. The thing that I think we can do differently is rationalize our approach of, which tools play when and how they're starting to your SDL. That requires you to know processes, but also culture of a company, right? I think we miss the cultural elements, the developers, the end user. That gets missed. You can do all you want on the other side. You will probably not see the outcome that we are looking for. We may still be talking about this 10 years from now. That to me would be the single biggest takeaway would be, hey, great, we have the technology. We know how to do this. And here's and Brook can chime here. I don't think it takes a whole lot of other rocket science things to get handle on some of the things we have known for 20 years. Then why can't we do it? The reason lies in us trying to approach it from a security and maybe technology perspective and missing the people and cultural elements of a company. Thereby, even if you solve it, and I have seen programs where you have solved, you bring things down to 0, and it goes right back up to where it is, because then you haven't really addressed the ongoing piece. You'll be back in the same situation on a hamster wheel in few months or few years.
Perfect. Thank you. So the next question is somewhat of a quote, which I found kind of interesting. And I just wonder what your thoughts are on this. I spoke to a CISO a few weeks back, and we were talking about attack surface in general. And he said, look, I've been saying this for years. You can either remove the vulns or reduce the attack surface. With so many, millions and billions of lines of code, is it even conceivable to reduce the attack surface, or are we now in a world where going forward we are manually or using tools, removing vulns everywhere we can find them as fast as we can to release code that has less in them? And Damilare, I'll let you take that one for starts. What are your thoughts on that?
Yeah, you got me thinking as you said that remove the vulns or reduce the attack surface and remove the vulns. I think that's what you said, right?
Yep.
And as I think about it, what is an attack surface? The attack surface is really another way that people look at attack surfaces are the entry points where people get to attack your platform. So if we think about even a house, your attack surfaces potentially are then your door and the windows to the house. Now you could have doors, that is a door in a place where there is little light, for instance, and perhaps there's a lot more risk in that area of someone coming into the house without you seeing them otherwise, or just put some cover for them, so to speak. And you might decide, instead of putting that door in that dark corner of the house, you decide to put it in such a way that it's facing the street and there's more visibility. So why am I saying all of that? Because I think that there's still something to do with reducing attack surfaces, because we're still thinking, when you look at an application and you think holistically, where do you need input to come in, and how do you design your application such that you're removing unnecessary entry point, unnecessary doors, so to speak, or putting doors in places such that now, I think even as I use the door, I don't want to use the door analogy too much. So let me go right back to the attack surfaces. And the long story short is that I believe, yes, we can still reduce attack surfaces, because all that means is, architecturally speaking, for instance, how do we design an application such that we have the right input points and just for the purposes that are required for that application to be successful. So sometimes you have entry points that we open and a lot of features, extra interfaces that are nice to have, so to speak, and are not necessarily enhancing the security of that system. But if one is thinking from that perspective that attack surfaces are the places where attacks come into your system, then do I need as many doors as I have in the house? Do I really need a door at that particular, shall we say, at the side of the house? Or do I just need one door in the street view whereby there is more visibility and I'm able to concentrate my efforts on putting the right protections at that doorway? So I put a lot of words there, but to my point being that, yes, architecturally speaking, it's possible to reduce the attack surfaces as we reduce and remove unnecessary entry points into our system, keeping our system functioning and focused on what is necessary and what inputs are necessary for the application to be successful.
Perfect. Thank you. And also, I just want to mention a couple of questions have come in from the audience, and we're going to try and keep about 15 minutes at the end for as many questions as the audience would like to present. Please do consider everyone on the panel as someone who can help you. So if you've got a specific hands-on, hey, this is the thing, please put them in the chat and I will be sure to address them. And this just came up. I think this is an interesting thought. Maybe, Brook, you'd like to speak to this, but I think one of the things that gets missed most often is matching the tool set to the architecture, or even reviewing the architecture for applicability at all. And that's from Francis in the audience. Brook, would you like to speak to that?
Architecture. Yes, it's fundamental. Structures. You know, the interesting thing about architecture is we have the architectures for some of the buildings in ancient Egypt. Humans have been making structural maps and representations for a long time. And I like to say, if something gets too complicated for me to hold in my mind, I start drawing the structure so I can remember where everything goes and how it relates to everything. So architecture is kind of fundamental to what we do. You can also use the word structures if you like. I don't really care, but we've settled in the software world on architecture. So architecture, first off, the thing about architecture is, back when we were really thinking about architecture, and I happened to be lucky enough to land at Cisco just as Cisco was participating in the creation of what we now call security architecture as a discipline and as a way of thinking. So that was very formative for me. And I was just lucky, pure luck, being there at the right time. And the reason they swept me up at Cisco is because I was a chief designer of software at a little software house. And so I had a lot of design experience, which lots of people came out of sysadmin as or development as Anmol and Damilare, and there weren't that many people who'd been doing a lot of designing. So they swept me up for whatever reasons. And I was lucky enough to be there because we used to think of architecture as something you do always beforehand. And if you sort of go back in the history here a little bit, 1996, NIST 814 says, yeah, do some architecture, security architecture before you start building. And that's the way people thought of things. Roll up to today. Some teams, if you're really doing agile, teams get to decide how they take the work. So they might very well say, I want to design while I'm coding because I want to learn from the coding and let the design breathe. Doing all your architecture up front, especially the security architecture, isn't really going to work very well. It's going to be out of sync very quickly. So one of my battles and one of the myths that I like to poke at is the idea that something like threat modeling is a point-in-time process. If you're doing Agile and you do your threat model point in time, and worse, you do it after everybody's finished whatever architecting they've done. How many times I've talked to a project and they've said, oh, come back when we finish the architecture. Think about that. That means that everything I find when I threat model, or we find together, because threat modeling is a group activity, will be rework for that architecture. No, threat modeling is the foundational process by which we figure out what security we want to architect in. Therefore, it is part and parcel of doing architecture. And if you're doing your architecture and your design while you're coding in parallel and they feed back into each other, and actually that's good DevOps thinking, that we're all running all the time and feeding back and talking to each other and learning from each other and getting better as we go, then really your threat modeling is what? It's part and parcel of all that work. It's foundational. It's a technique we bring to architecting, to figuring out what we want to do. And then your testing proves the threat model. It says, yeah, you got the right stuff, or look, you missed this whole big thing. And so when we talk about architecting, I want us to get away from, savants sitting there building 200-page binders of diagrams and descriptions that nobody ever looks at. They just sit on a, it's if we can make it integral to what we do, then suddenly it just becomes a foundational part of what we do. Just like what I said about SEMGREP helping you on the desktop while you're coding, getting that stuff right. Threat modeling is part and parcel of thinking about what we will do and how we will do it and what its structures will be. And the interesting thing about architecture, I just gave my students their architecture lecture this week, so it's hot in my brain, so forgive me. But it's not only how we think about structure, but it's our playground. It's a lot cheaper to play around on a whiteboard and go, yeah, what if we do this and what if we do that, than it is to actually build that stuff and then take it apart. So it's a mental playground. And so, I encourage people to architect. I don't know if I answered the question exactly, but, when we think about architecture, I want it to be integral to what we do and not some special thing on top. And that means threat modeling, integral to how we think about structures and designs. That's the security offering, if you will.
No, that's really helpful. It's funny. Also, Damilare mentioned a really great brick and mortar analogy, and I love those. And I think in terms of that a lot myself. And as we're moving from sort of the brick and mortar world of servers live in a warehouse somewhere in Chicago, and they're armed guards, and there's walls you can't drive trucks through, and there's all kinds of crazy fire suppression systems that suppress the lives of humans. I think in terms of everyone is moving to the cloud, things are very different, with regards to AWS. And next question, this one is for Anmol. You recently published a book which is Defending the Cloud, Waging Warfare in Cyberspace. Can you talk about sort of the different world we live in now with regards to cyber defense in a non-brick and mortar world of servers, and what people are doing or what methodologies are important to consider if, say, an organization were taking the first steps towards, hey, we're moving everything to the cloud? What do we need to get right from the start?
Sure. And Mike, the book was almost a decade ago. So, a lot has changed, because when I contributed to that, with James Ransom writing the book, it was a simpler world in many ways, right? We were exploring moving to cloud, early adoption of cloud about a decade ago. But we could see the challenges that I think if someone was to move into cloud today, probably don't exist. There are different elements of those challenges. The question I would ask is, if you're just starting your journey into cloud, why are you doing it, right? What is it that you want to get out of cloud? You make sure you really outline your end user experience and things in the workflow that should work well, and then use that to see how to build security processes and programs around that. The other thing I would ask you is, when you move to cloud, it will change some of the things that you do today, right? Even in the security world, some of the detection things that you may do in your data center may not necessarily be one-on-one replacement of exactly doing the same thing the same way in AWS. So what are those differences, whether it's in the tool sets or the technology, the way we use it, the way we process that information, or how do we react to it? AWS has a shared security model. So what falls under you versus what falls under them, right? Which IaaS, PaaS, SaaS layers are using? Those are the elementary questions I would start. Similar questions would be there for Azure or GCP. It's like, what elements of the security are you looking for? I think there's the security of the cloud and security in the cloud, right? And I think those are two very different things. And I often feel people focus on one and miss out the other. You need to really not only look at security of the cloud, in the cloud, but I would also say of the CI/CD build pipelines and deploying them securely, and the processes. And again, all of these are table stakes for getting things after that right. And I would encourage everyone to do that right of the bat, because waiting that is just going to make it worse for you. And I don't think you'll be in a position to solve this at scale. I do like to look at this as sort of managing your attack surface and not really reducing it. Yeah, I think when you start doing it early on, some of the stuff you can reduce and there are things you can do, but eventually you have to get comfortable with your attack surface being extended either through APIs or through remote work or your people or a whole sort of things, and you being okay with it and really managing it by building those defenses. So that would be sort of the last thing that I would say there.
What do you recommend, actually, just as a follow-on, for people who are working in the CI/CD pipeline? You mentioned using security. What specifically are you suggesting?
How do you integrate yourself with the build pipeline? So when you check in code into Git, does it get any sort of security validations? How are we looking for some of the hard-coded secrets? So really looking at from the check-in. Of course, the threat model precedes that, but check-in, and then it goes through the pipeline. How are you essentially using the AMIs that are something that security has built in? All the telemetry is part of your images. So from providing the foundational elements to your deployment phase, integrating into your build phase is what I mean by CI/CD.
So next question kind of follows on with that. With regards to the use of containers and security in general, my understanding is, typically there's a lot of open source being used, sometimes up to 80%. So Damilare, what are your thoughts on securing what you did not produce, like in an open source world? What can you do if you're using a considerable amount of open source code to ensure that you haven't introduced vulnerabilities via the open source?
Well, there are different layers to that. You mentioned containers along with open source, and let's see. So with open source specifically, what we should be aware of is, and um, Brook and Anmol, I've heard you talk about this before. With open source, we're doing things faster, getting our products to ship faster, but it's technical debt because you're really bringing in these components that you end up being responsible for a long time. So if we were to speak with open source specifically, one of the ways that people tackle this today is really using these scanners that I think I mentioned before, whereby you've got tools that are monitoring your code base, essentially, your code base for known vulnerabilities in those open source components. So that's one thing for components that you're bringing in, so you're aware of vulnerabilities as they are discovered and are publicly advertised, such that you can stay abreast or make sure that you're patching your software using automation as well with some of the smarter tools that are coming out today. Now, when we go to something like containers as well, one of the things that people can do with containers is, well, I think for starters, even just the attack surface, as you put a container together to really provide this environment for some particular application or function, you want to, as much as possible, you don't want things in the container except you need them to be, except they're really necessary for that application, because everything in that container, everything that is in that set becomes something that you're on the hook for maintaining. Another thing that people often do as they release into the container world is really just release a layer, essentially, or even so whereby as you're releasing a container, you don't have to create an image that has all of these different software components. You could just release a container, a layer such that your users then are able to take your layer that has potentially your application and are able to use that with some of the AMIs that already exist or that you recommend, such that for a software company, then you're not on the hook to maintain these large AMIs with all the software components in there. You produce layers that contain just your software, and just maybe if there are some other components that you think are necessary, so closely tied to your software, and you're on the hook just to maintain those pieces, and you've, in a sense as well, reduced the attack surface that you've got to be concerned with concerning the containers that you're publishing and then maintaining afterwards. So that's my answer there.
Nice, thank you. That's really helpful. So we have a handful of minutes left, and what I'd like to do is go through the panel sort of one at a time, and just consider this last question again, sort of like if someone came to you for some real world advice and just said, hey, look, I want to do this right. I want, I understand that security must match the speed of delivery. Delivery is absolutely ridiculously fast. The speed of light certainly comes to mind. And in the world we live in today, using methodologies and tools we have today, if you had a conversation with someone and they just said, hey, do you have any real world advice you could give me that's been helpful for you? What would you say to that person? And Brook, I'll go ahead and start with you.
Okay, well, I hope I don't trump on Damilare or Anmol. This is a multidiscipline, multivariate, multidimensional problem, software security. So if you don't think of it, if you try to think of it in a unidimensional way, you're not going to be successful. You got to start someplace. There are open source tools. You're going to need to make some investments if you've got any revenue or any backing behind you. If not, then you go with the open source, the best you can get. But you're going to have to realize, as we said, it's both craft and engineering, and the engineering involves tools. And so you have to look across all of that and address both. Don't just do one or the other. And the other thing I would say, just to keep this sort of short, is the best time to start is the moment you write a single line of code or start drawing a single structure and think we could do X, Y, and Z. Because you want to be thinking about security. It has to kind of be one of the ilities you're going to work. Yeah, maybe your proof of concept that you're only going to run on your laptop maybe you can let it go for that. But the moment you start thinking a little bit beyond that, you got to, you're going to have security challenges. And finally, I'll say, and Anmol said this, and this is really important, and I just want to underline it and echo very strongly. It's what my friend Nooper Davis, who is an incredible practitioner, please follow her, calls culture hacking. Wait, I love that. As a hacker, as someone who's written a lot of code and likes to experiment around and took my first virus apart and my first worm apart in 1992 by hand, hacking, yeah. So I still think of myself a little bit as a hacker. And I like this cultural hacking because that's what we're doing, really. We want everybody to understand that security isn't some special wart on the side done by someone else. It's one of the star ilities. I don't know who gave me that term. Maybe it's Cesar Tarandak, who also is an amazing practitioner. Star ilities, like, usability or whatever. Security is one of those. And that doesn't mean we're going to win all the time. The security people, they don't have the automatic trump card that says, no, do it my way, and I win. But it's one thing that you have to consider as part of your culture of delivering insanely great software, to quote Steve Jobs, I believe, is that we want to include security as just one of those things we do. And that's a cultural, in some places, that's a cultural change. And it's going to be hard, especially, I think, for some security people who think of themselves as policy drivers, to think of themselves instead as enablers and knowledge workers who have some special knowledge that they can add into the process, and a partner, a participant who's listening as much as dictating. Dictating is only to be used when it really as a last resort measure. That's the last resort. Mostly it should be partnering and, I hear your problems and here's this other problem. And, what are some ways to maybe get around it or get a little pressure now, a little bit now, and then we'll do better next time and we'll do better and we'll keep building on that and think iterative. That's what I'd say to folks. You got to start yesterday, but you can take this bit by bit, but you're going to have to take it on a bunch of different levels, and some of it is cultural. And as engineers, sometimes we don't like to think about that, but a lot of this is, as Anmol so beautifully said, there's a lot of people here.
Awesome. Thank you. So we only have a few minutes left, and I'd like to leave it like this. Everyone in the audience, first of all, thank you for your questions and for joining us today on this panel. This has been fantastic. I've wanted to bring these three people together for a panel for quite some time, and it's just amazing to get a chance to hear from this wealth of knowledge. And I'd like to encourage all of you to do two things. One, obviously buy all of their books. They're amazing. And two, consider this conversation ongoing. Honestly, please do link in with all of us. If you didn't have a question now, but something came up later and you're like, you know what, there's this thing, we'd like to be part of your community and we'd like to be an active part of that. So please do feel that you can reach out to us and mention the conference as a starting point so we know that we know you. And then, again, if any questions do come up, let us know. And on that note, I'm going to say, we'll go ahead and turn it back over to the Master of Ceremonies, who will end our panel. But again, thank everyone for joining us. It was a lot of fun having you. And Anmol and Damilare and Brook, thank you so much for joining me. It's just amazing to listen to you guys talk, especially all together on the panel where we get a chance to kind of hear a little bit of everything and spin off some ideas. So thank you very much. And we will see hopefully all of you again in the real world in person very soon.